back there? Okay, thank you. So last class session we covered reciprocal, the idea of how to graph a reciprocal function, and then we also addressed composite functions, how you take one function and put it inside another function. And you've actually been doing that, as I said in the last session, you've been doing that repeatedly over and over again. And today what we want to do is sort of switch topics a little bit, and where we actually reverse the inputs and outputs. And what that's called, when you do that, when you reverse the inputs and outputs, or in algebra using x and y representing your inputs and your outputs, if we reverse those, then we're essentially running the process backwards, running the process the other direction. And so that process is called forming an inverse, and then there's a special class of that which is then called where the result you get is actually still going to be a function. So that's what we want to look at today. The math is not very difficult. It's just a new process that you have to learn how to do. All right? So before we start on that, I wanted to just see if there's any questions from recent material. Jennifer?
Can you just verify something for us? On the vertical and horizontal asymptotes with the oblique.
Yes.
Oblique cannot have a horizontal asymptote, but can have a vertical asymptote, right?
Yes. If a rational function has, let's say let me just draw a sketch. Let's say it has an oblique asymptote that maybe looks something like this. Let's say it goes like this. It can't, the way oblique asymptotes work is that's what happens when x gets really large. The graph ends up approaching that, doesn't it? Okay? And then if x gets really large positively, or if x gets really large negatively, it approaches it. So let's say it's looking like this in its end behavior, to the right and to the left. It cannot have a horizontal asymptote, because if you've examined the end behavior to the way out to the right and left, and it's approaching this kind of a thing, it can't also approach something that's horizontal. Does that seem reasonable? Okay. It can, however, as you said, have a vertical asymptote. It might have multiple vertical asymptotes. So I could put something that had a vertical asymptote in here, maybe like this, and maybe there's another one over here. And maybe the actual function maybe looks something like this. The rational function maybe looks something like this, graphically, where it's got some zeros here and here, and it's got some end behavior off to the left like this, and then maybe it sweeps up here like that. And it's possible, unusual, well, let me just keep it simple. Has another zero over there. So it may look like that kind of a shape. Again, an oblique asymptote combined with some vertical asymptotes is certainly possible. Does that help? Any other questions? Okay. Ready to start talking about inverses? All right. Okay. Maybe. Okay. And it looks like quite a few people are still absent, so there's the flu bugs going around. So how many of you have had some illness this fall? Yeah, looks like the majority of you. Got a bad battery?
No, actually, you're fine, but we had a brain fart in here.
Uh-oh.
And we didn't have any audio to just now.
Oh, okay.
Can we start it over again?
Okay. Well, they only hear about a third of what I say anyhow, so if I repeat myself, maybe they'll catch it. That's okay. That's all right. I don't mind. Okay, the previous class session we talked about, let's see, what did we talk about? Rational functions and with oblique asymptotes and horizontal asymptotes and vertical asymptotes, zeros, and end behavior kind of issues. And what we need to do now is transition into where we're going to take a function, and it doesn't actually have to even be a function. What we want to do is we want to reverse the inputs and the outputs. And doing that, when you reverse the inputs and outputs, it's called forming an inverse. And then if the result, when you do that, passes a vertical line test graphically, then we call that an inverse function. So what I'd like us to do is go back to week 1 of the course and take a look at a circle. So see if you can write down the equation of this circle. I'm just going to draw a circle, and you should be able, this is a good review for you. Let's put the center, why don't we put it over here at, say, -3, 1, and let's give it a radius of, say, 4. So to the right would be here, to the left would be over here, down 4 and up 4. Looks pretty good. So the circle's graph will look something like this, right? And it's got a radius of 4. So this point up here at the top would still be at -3, but it's going to be up at 5. And the bottom is going to be 4 below the 1, so it'd be down here at -3, -3. So write the equation down over there. -7 and 1, and this point would be 4 to the right of that, would be at 1, 1. Okay, my drawing is not too accurate. Okay, feel good? Have you written the equation down? Okay. So what you should have written down, based on the material we studied back in the first week of the course, is it's of the fundamental form x squared plus y squared equals 4 squared. That would be a circle centered at the origin with radius 4. And we're going to shift that thing to the left 3 and up 1. So by shifting something, replacing x with x plus 3 is what you should have written down. And shifting it up 1 is going to replace the y with y minus 1. Did everybody have this equation? Okay, good. So now, what's going to happen if I decide to take this relationship, here's its graphical representation, and I interchange the x values and the y values? What's it going to do to all these points if I interchange them? Isn't it going to reverse it? This is going to become a 0.5, -3, which is going to take it from up here in the second quadrant and make it 5, -3. It's going to take something in the second quadrant and move it down into the fourth quadrant. What's going to happen to the 0.11? Stays right there. -3, -3. Stays right there, doesn't it? -7, 1 becomes 1 minus 7. Right? Okay. Let's draw that picture. If we interchange the x and the y's, here's what I like to do. The books don't do it this way, but this tells me what I've done or what I'm going to do. I'm interchanging the x and the y, so my equation would simply transform itself into being y plus 3 quantity squared plus x minus 1 quantity squared still equals 4 squared. Now normally we're going to write the x material first for an equation of a circle. So we'd write it as x minus 1 squared plus y plus 3 quantity squared equals 4 squared. And if this was the equation or the relationship that was originally given to you, you would just simply draw the sketch based on what you see here. And so let me try to do that, and let me try to do a little better job of sketching. Shifted 1 to the right and down 3. So the center's here at 1 to the right and down 3. And then 4 above that is here at 1, 1. 4 to the left of this is over here at -3, -3. And then the bottom point is down at -7. Just barely making it here. And then finally off to the right. Oops. Out here, it looks like it should be 1. I'm sorry, it should be 4 to the right of that. Would be at 5 -3. So I've labeled 3 of the 4 points and the center as well. And then the graph is going to have some x-intercepts and y-intercepts in there. And so if I can draw that, the graph will look something like this, roughly. The reason I wanted to draw it a little more accurately than what I did previously is because I also want to draw that original one that we started with, which had its center at the where we had these coordinates reversed, -3, up 1, and then 4 to the right was here, and then 4 below was down here. Oops, how come that's, actually 1, 2, 3. This point I misdrew, sorry. Let me correct that. Catch me when I make a mistake, folks, because I do make mistakes occasionally. That's why we use pencil doing math, isn't it? Okay. And that's why I have an erasable marker. Okay, that looks a little better. And then the new circle goes through this point. This is the bottom of it. And then 1, 2, 3, 4 to the left is here. And 4 above. It's up here. And this was at -3, 5. Double check these points that I'm labeling just to make sure I did my arithmetic right. -7, up 1. And I think we're okay. I'm going to make this circle dotted so that you can sort of see a connection here. That's not too bad for a hand sketch. Is that all right, folks? Okay. Is that all right, everybody? What do you observe? We interchange the x and the y between the two equations. The original equation I'll write up above here was x plus 3 quantity squared plus y minus 1 quantity squared equals 4 squared. There's the original circle. We interchange the x and the y, forming what we call an inverse. And then here's the equation of it, which we also drew then in solid line. All right?
And you said that the third line is the equation of it? Is that what you said?
Well, this is the way you usually write it.
That's the way that you want it written?
Yeah. I mean, this is okay too. All we did is interchanged x and y. So we're looking at this original one up here at the top and this one down here. Now, what do you observe about the graphs? And that would occur no matter what graph you started with. It looks like there's some symmetry in the pictures, isn't there? What sort of symmetry do you observe? Not this origin symmetry. Doesn't it look like symmetry along a line like this? Doesn't it appear like we have taken the original graph here and simply rolled it over this y equals x line, we rolled the original graph, like spinning it, over the y equals x line. And notice that the points, minus 3, 5 becomes 5 minus 3. 1, 1 stays 1, 1. Because it happens to be right on that line, and if you interchange, look at this, if you interchange x and y, don't those points stay on that line? So what I'm trying to help you do is to make some general observations about an initial relationship that you might have a sketch of and what the inverse will look like in general. Doesn't have to be a circle, it could be any picture. I could draw a smiley face somewhere.
So they're all going to cross that y equals x?
They roll over it. If you roll it over, you're going to get the inverse. You're going to get the inverse. Not too bad. And you see how you change the equation? You simply interchange x and y. That's not too tough. That's not too tough. Okay, now let's see it in the context of a function. Is this original circle a function? No, because it does not pass a vertical line test. For any given x in the domain of this relationship, I'm looking at the dotted circle here, in any part of this domain from -7 on the left over to +1 on the right, anywhere in there, if you pick any x value in the domain, you see 2 possible y values showing up. Except on the endpoints where there's only 1 y value, okay? So by having 2 possible outputs for a given input, this is not a function. What could you do to this original circle to make a portion of it a function? Cut it in half. Take maybe the top half of it. That would certainly be a function, wouldn't it? Now let me just do this. I don't want to spend too much time on this particular example, but let me just hash that like that, okay? Where is that portion? Where is that portion on the inverse? This part becomes what part over here?
Well, if it's rolled, it should be the top part, right? Because it's just rolled across, it's not rolled down.
Let's roll it, okay? Let's roll it. If you're not sure, you could take a piece of paper actually and you could fold it. You could fold the paper along that 45-degree line and see the image of it. Take some points along with it. That's a nice way to do it. So I'm helping you with what you'll see when you do homework, because you're not going to be doing a circle. You'll be doing other kinds of things. But I'm helping you see the general pattern. So take some points on what you see as a function. Like, for instance, this point's going to be a good one, isn't it? So that becomes that. 1, 1's still good, and -7, 1 is still good. That becomes 1 minus 7 down here at the bottom. And then, let's see, what about this point? Where is it? Where is this point right here? Where does that point go? Watch this. You'll like this. If you ever have the sketches, you could take a point like this and go perpendicular to the y equals x line, across there, out the other side, to a mirror point. If I took this point that I just drew as a big black circle, I'm going to roll it across that line. Where does it show up? Right here. Yeah. Okay, and where is this point right here? Let me put a big black X there. Where does that point show up? Down here, isn't it? So what portion of this original graph shows up in the inverse? The right side of it. The right side of it. So let me draw it kind of weird looking here, looking like that. There it is. Do you see how if you take and roll this original hash mark thing over, you get that portion? You don't get the top of this lower circle or the bottom. You get this upper portion here rolls and becomes that portion over there.